Welcome back! 2 weeks ago I took apart this Siemens Attane A210 symmetrical DSL 2 ISDN and Ethernet box. After the fact I dated that thing, very late 1900s, very early 2000s. And the board was really, flooded with chips, and you had everything. You had FPGAs, you had DSPs, you had a whole slew of application-specific stuff like ISDN subscription controllers and Ethernet controllers and DSL controllers and a whole lot of 74 glue logic. Yeah, it was a feast. Card here, link in the description. Now I have the same but newer. Wrong way around, sorry. Siemens se7950. And we will have a look what's inside here. Enjoy! Its front is almost featureless, but for the label Siemens se7950. However, if you zoom in really close and shine some light on it from the side, then you see, there are some bright spots here and there that are lurking behind that otherwise, that's a good shot, otherwise flawless plexiglass front. Looking at the top, that features a lot of ventilation slots and another Siemens label. The secret behind these bright dots is revealed here. There are indicator LEDs for power, test, wide area network, local area network and voice. That's ISDN. Of course, if you have a whole stack of these boxes somewhere in your 19-inch cabinet, you cannot read the labels. Seems that in the newer generation of these DSL to Ethernet plus ISDN boxes, design won over function. The backside, which you probably would use as the front side if you put it really into a 19-inch cabinet, features a DSL connector, a management console, so probably some serial interface connector here, no longer the big clunky D-type 25-pin connector, but something smaller. Then here 10 100 megabit Ethernet connectors, 8 of them, so it has an inbuilt Ethernet switch. And here the voice connectors, so 4 times S0 ISDN. Lots of configuration dip switches, a power connector, some LEDs and a real power switch. Most of the LEDs we saw at the front are repeated here. So power, test, wide area network, so basically DSL, voice, and then we have that on-off switch and a 12-volt connector, 4 amps, so about-ish 50 watts. The older model needed 48 volts, 1.1 amps, so also about-ish 50 watts. 48 volts are needed for the ISDN telephone lines, so I guess they will create the 48 volts internally here somewhere from the 12 volts. Both sides are almost featureless, but for these, little holes here. These holes seem not to be threaded. I guess you can clip in here some brackets so you can screw these things into an actual 19-inch cabinet. On the bottom we find 2 labels, made in China, more ventilation slots and most importantly 4 screws. No snap-in bullshit holding that case together like the older model. However, these two stubs here, they look like snap-ins. The labels are not very informative. We already saw that it's made in China. Anyway, again, it's a Siemens model SE7950, ISDN IAD. IAD means Integrated Access Device. Yeah, who comes up with those abbreviations? Voice and data. I mean, voice is ISDN. Yeah, okay, forget about it. It takes DSL and gives you ISDN and Ethernet. It has a part number, it's revision F, it has all the credentials that are necessary. And we have here a MAC number, probably for the Ethernet interface for the local area network. It's at least assembled in the USA, even if it was manufactured in China. And yeah, unfortunately, no date of manufacture anywhere. The power supply that came with it is a Fihong made in China. Okay, 12 volts, 4.2 amps. So they gave us a 5% margin at least. All the necessary certificates, and here is a pinout. The connector obviously has 3 pins. 2 of them are RTN, so return, that is ground, and 1 is plus, and the shell, so the shielding, is not connected. That's also a big difference to the older one, where we got mains earth routed here through the low voltage connector to our actual box for shielding purposes or whatever. Unfortunately, that Chinese power brick is also dead as a dodo. Yeah, there's nothing going on here, so we won't even try to switch on the whole thing. But it also has a locking, I thought it was locking, sorry, a kind of a locking power connector. Yeah, now it's locked, now it's unlocked. Yeah, locking connector. Good thing. So, without further ado, let's take that thing apart. It should be only 4 screws, which are of the self-tapping type. Okay. And now we should be able to... Yeah, it's already cracking. Something broke inside here. Okay, that plastic didn't age well. So, yeah, I think there's even a crack here on the top. Yeah, we already see the board and chips of plastic that just broke off here. A lot of the cracked plastic is from that post here, which is also screwed on. Cannot completely remove it though. That screw hit here behind the label. Okay. The board itself is indeed snapped in here, and these are going really smoothly. And now I think we should be able to just lift it out, back, out, whatever. More snap-ins. Okay, got it out. So that case is made of polycarbonate, that were the transparent parts on the outside, and ABS. And I had no idea that ABS can get so damn brittle. These were all pieces that were just, breaking off. Please note that the plastic case is also not metallized on the inside, like the case of the old model. Who needs shielding? And here's the board. So we have here the 5 front LEDs on some risers. Then power comes in here on that side. And we have here, well, we will see a big switch mode power supply, more switch mode power supplies, but all, yeah, with discrete components. More switch mode power supplies with discrete components, backup battery. And then DSL comes in here through two real fuses, yeah, fuses. Isolation transformer for the DSL line, probably the transceiver for the DSL line. The DSL controller, and then through some routing we go back out here into the 8 Ethernet ports, isolation transformers for the Ethernet ports, and Broadcom. That's probably an Ethernet switch chip. In between that serial port, it's really, yeah, just here a transceiver. The rest is probably done up here. And then we come, again, you can't see it, but we will zoom down in a second. We have here DSPs, okay, digital signal processors. And these feed these ISDN subscription or subscriber management chips, and then we go out here through these ISDN isolation transformers into the ISDN ports. Here are the configuration dip switches with a lot of resistors going somewhere, and that's it. We will start here this time systematically with the DSL input and going down this strip here. DSL comes in here, then we have two real fuses, and that little thing here, that's a P31B, a protection thyristor, and it completely opens up at 350 volts, shorting out both lines and hopefully blowing the fuses. That is followed by a common mode choke. And that side job here, that's from Lucent, an LH146 SAAE. And I have no idea what that thing is doing. I came up completely blank. Maybe it's a custom chip for Siemens for especially that product. Anyways, if we go further down, we find our DSL isolation transformer. And then this little bugger, which is a globe span Virata. GS3137-08-T. That's an SDSL transceiver, maximum 2 megabits per second, which is followed by a Globespan again, GS2237108. By the way, Globespan has been bought later on by Connexent, I think. And its associated oscillator, the 34.560 megahertz. And then we are already off to the power supplies here, which obviously provide 5 volts and 2.5 volts and are controlled by these little thingies here. That's marked LT and B. That's actually Linear Technologies LT1616 600 milliampere 1.4 megahertz. Yeah, 1.4 megahertz. Really small inductors. Step down switching regulator, and that thing is not an external MOSFET, that is just a diode. I looked into the datasheet and that thing needs a big diode and a smaller diode to run. Yeah, and we have 2 of these. So we had DSL in here, and up here approximately we have now digital data available, which is probably going over into that block, and that's what we will look at next. And we start with the lower left. These are more LED risers where we find a battery, and then these two thingies. And that's a DS1302Z, a timekeeping chip, also known as real-time clock. And that's the accompanying quartz of 32.768 kilohertz. Besides them, we have some, well, Intel flash memory. Yeah, let me remove the sticker. Maybe we can make the type number readable. I destroyed the markings just a little bit, but I'm pretty sure it's an Intel TE28F320B3. That's a 2 mega by 16-bit, well, flash. And beside the flash, we find a Micron 48LC2M32B2. That's an SD-RAM, 4 banks of 212K times 32 bits. And I guess they provide the program and the data memory for either that jobby or that one. Well, that one here is an NXP MPC 180 LMB, a security coprocessor that does decoding and encoding of, for example, IPsec or SSL or TLS. And that's usually slaved on the data and address bus, like the two memory chips, to a communication processor. And that would be that Freescale XPC 855T. The rest of the number is really just packaging and stuff. That's a quad integrated communication controller from the PowerQuick with CC at the end series. And we shouldn't forget about that little bugger down here. That's just a Dallas Semiconductor DS1233A reset controller, 3.3 volts, probably providing a reset signal for that thing. Above our communication controller, which makes sense of the different data streams delivered by DSL, we have here a 4 MHz quartz, an inductor, and a cute little patch wire. Ooh. And another sticker. The sticker hit an Altera EPM3128A. The rest of the number is really just packaging and stuff. That's a CPLD, a complex programmable logic device. 2,500 gates, 128 logic blocks, and 98 I/O pins. And above it we have LE244A. I couldn't find anything with a LE prefix here, but that's basically a 74244A, an octal 3-state buffer line driver. Side note, that's the first glue logic we saw on this board so far. I almost skipped over that quartz here on the side, 2.48 megahertz or something. And that little bugger here, that's an LM2917. Frequency to voltage converter. Maybe some, I don't know, VCO stuff going on here. Above our CPLD and our communication controller, we find that Broadcom BCM 5327M. That's an Ethernet switch. However, if you believe Broadcom, it supports only 7 ports, which is a bit odd, as we will see in a second. Anyway, that's probably supported by that 25 megahertz oscillator. And then that little jobby here, that's an 74AC08, a fast quad AND gate, probably doing some driving work for the oscillator or something. I said it's odd that Broadcom says this chip only supports 7 ports, because we have here at the back 8 Ethernet ports. And of course we have here 2 quad Ethernet isolation transformers. And before I forget it, here on the sideline is a little linear technology LT1381CS. That's an RS232 dual driver receiver, and it only needs a 5-volt supply, and with the help of some capacitors it makes its own plus minus 13.2 volts for driving the RS232 lines, which are connected here to that connector here, which was marked at the back with console or something. We just went down that slice here, so where the data from the DSL line meets our communication processor and is split into Ethernet, which is further down here, and of course a part is split into ISDN data streams and goes over there. So let's have next a look at that ISDN slice. And there we greeted, just at the edge of the board, with another 74LE244A, an octal 3-state buffer line driver. Right above it we have 2 GSI GS72116 ATP-10 asynchronous SRAM 128K times 16-bit, 10 nanoseconds access time, plus a 16 MHz oscillator that runs at 3.3 volts. And those are of course supporting our DSPs. 2 times Texas Instruments TMS 320 VC5416 PGE. Yeah, 40-bit ALU, 17 by 17-bit parallel multiplier with a 40-bit adder, 128K times 16-bit RAM and 16K times 16-bit ROM. These are almost the same DSPs, maybe a little bit newer models than we found in that other Siemens box. And our 2 DSPs talk to these 4 ISDN subscription access controllers, which are driven by this oscillator 7.68 MHz. And we have here, as always, Infineon PB386F ISDN subscription controllers, and these are the direct successors of the subscription controllers from Infineon we saw in that other box. By the way, they obviously don't need an ISDN power manager chip. And the 4 ISDN subscriber access controllers are of course connected to our ISDN isolation transformers. And then finally on the ISDN connector side we have, interestingly, fuses. F27 for example, that's a fuse. Or it's a resistor, R614. Maybe they are MOSFETs or fuses combined. I don't know. I didn't find anything about these. And also interesting, but a little bit annoying, I didn't find anything about these thingies. Which might be just an inductor array. Yeah, there's a lot of LLL here around. Or they might be common mode chokes or whatever. And maybe they also have resistors integrated. Yeah, this section here is really confusing. That leaves us with just that strip here, which contains a lot of power supply stuff. That strip starts with an unpopulated 1.8 volt regulator, probably intended for something that would go here, another module or so. And then we have two 3.3 volt regulators, both using linear technologies, LT1767, 1.5 amps, 1.25 megahertz step-down switching regulator. A bit further up we find another lone 74LE244A octal 3-state buffer line driver. A little bit far away from the digital action, but nevertheless. And this is a linear technology ADR421 2.5 volt ultra precision low noise voltage reference. And these two are followed by another switch mode step-down regulator, output voltage marked BCM VCC, and it uses the same linear technology chip LT1667 1.2 amp 1.25 megahertz step-down switching regulator. And then we have that thing here, and I have nothing. So it's also linear technology, the stamp is 235 and it has 16 pins, and as I said, I got nothing. But since it's very close to the big transformer here, and that little package there marked Q1 is probably containing one or more MOSFETs to drive that transformer, I guess it's a switch mode controller. To be exact, a step-up switching regulator. Remember, we need somehow 48 volts or so for the ISDN lines, and this section is obviously producing them. Here are the rectifying diodes, 4 of them, and then this goes through 2 dual common mode chokes and is routed probably here to the ISDN connections. And if you have a closer look here, it says plus 40 volts, 1, 2, 3, 4. Comparing that newer board to the older board, which we had a look at 2 weeks ago, which both do basically the same, there's one difference that is very obvious for me. So all the 74 glue logic that was here on that board is basically missing now. So I think we had 3 octal buffer line drivers, 3-state of course, and somewhere an odd quad AND gate. And that's it for glue logic. Also, the linear voltage regulators are replaced by switch mode power supplies everywhere. Other differences, well, we are missing an FPGA. That was that big Xilinx thingy here. So that functionality must have been moved or taken over by some of the application-specific chips. Otherwise, it's exactly the same architecture as, let's say, 10-15 years ago. And this is a bit of a surprise. Especially, I can't get over the fact that they need DSPs to convert an internet data stream. There is ISDN over internet, by the way, or maybe they're converting a voice over IP data stream to ISDN data streams. And there's obviously no dedicated chip for that job, so they have to use DSPs. And yeah, the DSPs are here, 2 of them again. So that's kind of surprising for me. Otherwise, this board consumes, we saw that in the beginning, about 50 watts. Okay, given it has a not only one single Ethernet output, but an integrated 8-port Ethernet switch. However, they do that with a 7-port chip here. And yeah, but this thing also consumed with all the linear regulators aboutish 50 watts. So yeah, no real progress there. That's it for today. Next week we will continue with our mighty Melexis tri-axis magnetometer chip. We'll see how that goes. Until then, bye.